All right, so welcome to CSE 223 and what has been the weirdest school year, probably the weirdest year in general in my life. But hopefully everybody is doing well and staying safe and reasonably comfortable. And we are back on track as of today. We only have 8 weeks in this quarter instead of 10. But we will make that work. We're going to go a fair bit faster in the beginning, and then we'll level out to sort of a more normal pace for the course. But part of that speeding up in the beginning means I'm not going to spend the first 2 or 3 days talking about the syllabus and administrative details. You've had me before, most of you, so you kind of know the general way that these classes run, and everything is available on Canvas. Okay, so I just want to run through a few things really quickly, and then I want to jump into learning about object-oriented programming in Java. And so again, if anybody needs to talk or something, go ahead and raise your hand. I'll stop talking and then just use your microphone, and we'll see how that works. So first thing on Canvas is just this: be sure to read this. Everybody who's here already knows this apparently, which is that we are meeting through Zoom. We're meeting at the regular time, which is daily, 10 o'clock to 10:50. If this meeting code changes, I'll announce it through Canvas. Okay, so I don't have a password on here and so on. If we run into troubles with people Zoom bombing or whatever, this might get updated. Final exam will be at the original scheduled time, although if you look on Clark's website, it'll say there's no final exams this quarter. We will have a final for this class. It'll be Monday. It may continue on to Tuesday, okay, because we only have 50 minutes per day. The other thing I want to point out is because we have only 8 weeks, the programming assignments are not 2 weeks each, okay? They're going to be shorter than 2 weeks. And so make sure you're paying attention to the due dates. And as usual, if any questions come up, best way to reach me is email. I have my email on during class time. So if something goes wrong, you get disconnected and can't get back to Zoom or something, shoot me an email right then, and we'll try to deal with it at the time. All right, I've also posted on Canvas this resource of the week. This is from Student Services, and you can read this on your own, but basically, you know, there's always good support for students from Clark, but that's been amped up even more given our current situation. So if you're having any issues, financial, food, place to stay, things like that, talk to Kath Busha, talk to Student Support Services. There's contact information in here, and you know, if you're comfortable, just come and talk to me, and we can brainstorm and figure out what to do about whatever the situation is. The syllabus itself is pretty much the same as it always has been. I added one extra note in the top. Internet is laggy. That's weird. Maybe Canvas is just flaky. So syllabus, I put a note up here again just saying that this is a remote class. It's not online. You can't just, you know, go to Canvas and do the course. You have to come to class and participate and so on. So you can find the downloadable text here. You can see the outcomes, and you know, if you have any questions about this, talk to me. Let me talk about grading though, right? So 5 programming assignments plus the mini startup assignment due on Wednesday. That's 30% of your grade. A few online quizzes through Canvas, which I'll open up somewhere in the short-term future. That's 10%. Service learning project 10%, and then midterm and final 20 and 30% each. Everything else in here you should read through, but it's mostly stuff you've seen in other classes, with me at least. So hopefully no surprises there. And then additional information. So again, meeting code, meeting time for the classes. Office hours, so go to engrcs.com/schedule. You'll find my hours there. Mostly my hours are 8 a.m. Monday through Friday. Wednesdays I might start doing 7 a.m. I've got 7 a.m. this week. but it's going to be early morning right before classes start. And then I have some lab hours for Engineering 250 Tuesdays and Thursdays before noon. Those are priority for Engineering 250 students, but if I'm available, you can certainly find me then. You can always talk through Discord, mention my name if you want to get my attention. And you know, we use this in 224, 222, so it's the same Discord setup. And the policies are basically the same as they were in 222 and in 224. And I know why I can't click on tabs, because this little thing up here is stealing my view. All right, any questions about any of that? That's kind of it for administrative stuff. All right, cool. Yes, Aiden.
Oh, my bad. I was stretching. I'm sorry.
Oh, that's okay. Awesome. I was looking at kindergarten through second grade standards for computer science this morning, and somewhere in here, yeah, item AP14, debug errors in an algorithm or program that include sequences and simple loops. So yeah, debugging, it's your friend even in kindergarten through second grade in Washington State. All right, so let's talk about Java. So CSE 223, it's an advanced data structures course. It's also an object-oriented programming course. And the language we learn in here is Java. Okay, now some people do C++ for object-oriented. Java is a little more modern. Well, it's more recent than C++, but it's probably a little more used than C++. Java underlies a lot of systems, including Android. But basically, if you learn one object-oriented language, you can move from one to another. It's the concepts of object-oriented programming that are sort of most relevant here. And this feels a little weird, like talking to an empty screen. So. So yeah, I'll throw my face on for a few minutes. So object-oriented programming, what's the basic idea? Here's the 4 or 5 minute upshot of objects. We program in C, right? We have variables, so I is an integer, and C is a character, and S is a string, or an array of characters. And those we can think of as objects, right? When we say integer I is a thing that holds, 32 bits that we can interpret as an integer. When we have a character S bracket 120, it's an array of 120 characters, etc., etc. Okay. When we want to manipulate data in C, we can do things like, for example, find the absolute value of an integer. So we have an absolute value function, we can say absolute I. If we have a string and we want to know how long it is, we can call a function string length, and we can say string length parentheses S, and it'll tell us how long the string is. And if we have a character and we want to convert it to uppercase, we can call a function toUpper parentheses C, and it'll turn C into uppercase. So we have pieces of data, and we have functions that manipulate those pieces of data. And they are very separate things, okay? We could call the toUpper function with an integer. And if we passed it the integer 97, it would give us back the integer 65, which seems kind of weird. We could call the absolute value function on a character, and that might do something. We could call the string length function on an integer, and it'll probably segfault, okay? So we have, on the one hand, these pieces of data, and then on the other hand, we have these functions that we can use to manipulate data. And they're really kind of separate from each other. There's nothing inherently about this function and this piece of data that says these go together. We just have to know, if we're trying to do string length, we got to pass it an array of characters. So the idea of an object in object-oriented programming is we not only have a piece of data which has, a value or a set of values associated with it, but it also has functions associated with it. So when we declare a string in Java, it's not just a collection of characters, it's also a function for finding its length, a function for converting it to be uppercase, a function for looking for a substring inside that string, a function for converting it into some other format. Okay? When we have an integer, we don't just have an integer, but we also have, functions for manipulating integers. When we have a double precision number, we also have a function for converting that into a string, for example. So the basic idea of object-oriented programming is we don't just have data. Okay, we have data, but with each piece of data, we also have a set of functions, which we call methods, which can manipulate or modify or interact with that data. And it very naturally extends the idea of, say, an integer or a string to something broader, something that includes everything we need to manipulate it. And now we don't need to figure out, let's take the string length function and let's pass this string to it, right? The length, which is a function, is a part of this object. Okay, and so we'll see examples in a few minutes of what this looks like in code. But I would say don't spend too much energy up front trying to figure out exactly what an object is. Okay, it will become clear as we start working with them. Okay, terminology. Objects are like variables. Okay, integer I, we can think of I as a variable, we can think of I as an object. We'll also use the term class. A class is basically a type of variable. So if we have integer I, integer is a type of variable. Car is a type of variable. Okay, we're going to call those things classes in Java. So there will be a class called integer, there'll be a class called car, there'll be a class called string. And these are types of variables or types of objects. So string will be a class. When we say string S, S will be an object of type class. Okay, so let me switch to my document camera, and let's look at the programming assignment. All right, so I posted this a while ago. This is your first programming assignment. It's due, I believe, on Wednesday. I think I made it due Wednesday. This is a hello world, okay? It's a program that's just going to print out hello world, and I've actually given you the source code for the program right here, so you don't need to know Java, okay? This is the practice in typing in the code, compiling it, executing it, and then submitting it through GitLab. Okay, and that's really the point of this, is to make sure I've got everybody's GitLab ID, make sure everybody has a repo and knows how to add me as a reporter, and so on. If you were in 222, this is old hand to you. If you weren't in 222, I sent you an email and talked to you about this. Some of you have gotten back to me. If you're not comfortable with this, please, please, please talk to me today. Okay, don't wait for office hours tomorrow. Talk to me today through email, and we'll figure this out. Okay, so what are you doing here? You're making a program called pa0.java. And unlike C, if we're making what's called a class named pa0, it's got to be in a file called pa0.java. You can't just pick an arbitrary name for your file. So make a file called pa0.java, put these lines in. This is print line, println, that's an L, not a 1 or an I. Case is significant. You can copy and paste this, but go ahead and type it in, because you're going to end up typing this about 1,000,000 times in the next 8 weeks. Okay, so it's good practice. Type that in, and then to compile it, instead of GCC, we just say JavaC. That's a Java compiler. And then you got to put in the full name of the thing you want to compile, pa0.java. And then when you're, if that runs without any errors, you can execute by saying Java pa0. Okay, and that'll give you your output. So then, go through the usual Git setup. Make sure you've got a Git repository. Make sure your pa0.java is in your repository. Do your git remote add origin, your one-time setup to link this to a GitLab repo, and then do a git push origin master to push it over. Okay. This assignment only. If you're not sure if this worked or not, send me an email today, and I'll check your submission. Okay. So let's let's run through that live. So pa0.java. And it's going to be a few weeks probably before we actually understand everything that we're writing in this program, particularly public static void main. Why do we need all four of those things? It's going to take a few weeks till we get to that point. But you can take it as a mantra, right? Just kind of like integer main argc, argv. When you want to write a main program in Java, we do it like this: public static void main parentheses uppercase string, any variable you want. Like that. Okay, and this stuff in here, this is the body of our main program. Okay, this stuff up here, this is defining a class. Okay, it's going to let us create an object of this type. Take that as just what we do for now. Okay, the main program we're writing basically goes inside here. So this is our public. This is our void main, argc, argv. So instead of printf, we use system.out.println. We can do a \n, but we don't need to. Okay, println, the ln says put out a new line at the end of our print. If we did system.out.print, it would be like printf. It would not automatically do a new line. So we can just println hello class, and that should give us what we need. So let's compile that. And let's run it. Yeah, so you run it with just Java and just the name of the class. And there you go, it executes. Okay, so that's your hello world in Java. Very straightforward. All right. So let's just look a little bit at a few of the details on this, but then I want to mainly talk about the programming side of things. But you know, I have two files: pa0.java, pa0.class. Pa0.java, that's the file that I was writing. Okay, that's the human readable version of our program. That's the source code. Pa0.class is a compiled program. It's generally not human readable. Okay, it's the gibberish you see if you try to look at your main program that you compiled from C. Same thing, but it has some human readable stuff in there, right? It's got the string that we're trying to print hello class sitting in here, but you know, it's got all this other stuff that is meaningless to us. Java is a compiled language in the sense that, you know, we need to say Java C to turn our human readable code into that machine code, but it's also an interpreted language. If I just try to run pa0.class, right, it tells me it's got a format error. This class file, this binary file, is not executable on the hardware of my laptop. It's not x86 code, it's not ARM code, it's a different sort of binary code. It's binary code made for a virtual machine called the Java Virtual Machine. So when you say Java PA0, Java is a program, okay, written in C. It's a program that basically interprets that binary code in pa0.class and runs it for you. Okay, so Java is actually an interpreted language, like Python, like MATLAB. It does not run natively on the underlying hardware. It runs on this virtual machine called the JVM, which itself runs on top of the underlying hardware. Okay. So that's a little different, and that gives you a performance hit, but you know, it's fast enough now. The JVM has gotten really good, and CPUs are fast enough that we don't really notice the performance issues as much as we used to when this first came out. All right, so let's make a new function. Let's call it fun. And let's call a function. So let's do an integer I equals 10. So I'm going to make a function called times2, and it's going to take an integer argument, it's going to double it and return the value. And so I'm going to set j equal to basically 2 times 10, and then I'm going to print out what that is. Okay, so print statements in Java are a fair bit nicer than they are in C. I'm printing out a message here which says times2I returned, and then I want to print out the value of j. I can just say plus j. Okay, this plus is a concatenation. It's not doing arithmetic addition, it's saying take this string and append to it this string. Well, j is not a string, j is an integer, right? I said integer j. But when I try to concatenate j to a string, it will turn j into something that looks like a string. In particular, if j is equal to 20, it'll turn it into the string 2 followed by a 0. Okay. Now, if I just try to compile this as is, right, I will get an error saying cannot find symbol times 2. Okay, so method means function, times 2 int in this class fun is undefined. So let's write a function. So public int times 2 integer input, and let's just return 2 times the input. Okay, I'm going to do something. I'm going to ask you to forget it after I've done it. Okay, I'm going to put the word static in here. The reason I'm putting the word static in here is because I'm not really writing objects and classes yet. I'm really doing C inside Java. And so our main program is what's called a static, and because of that, the compiler is going to force me to make this function also be static. Okay, but I want you to forget that, because once we start working with objects and classes, we generally do not want to use the word static anywhere except in public static void main. And if you try to compile and it starts complaining about static, you can start putting the word static in other places, and you can get the compiler errors to go away, but not necessarily get your program to work correctly. Okay, so in general, we're only going to say static when we say public static void main. But just for now, just to show you the idea of a function, I'm going to use it here. Okay, but forget that I've done that afterwards. So we can compile this. This runs fine. We can execute it by saying Java fun, and it says 2 times I return 20. Okay, exactly what we would expect. So we have functions, we have integers, we have assignment statements, we have print statements, we have a return keyword. All the stuff that we do in C works in Java, okay, or has some corollary in Java. And the code of Java, the syntax of Java, looks a lot like C. I mean, it's derived from C, right? There's semicolons at the end of statements. There's for loops. There's while loops. There's, int and char and float and double. So if you know C, you can write Java, but you don't want to do that, right? If you only write C code in Java, you're really missing out on the benefits of Java being object-oriented and so on and so forth. So let's talk a little bit about objects. So let's make a new program. And I'm tired of typing all this stuff over and over again, so I keep copying and pasting. So let's look at strings. Okay, so let's say string s1 equals hello, this is a test. And then let's print that out. Right, and so again, I'm doing concatenation. I'm going to say s1 equals, and then I'm going to print out I'm going to append to that the value of S1, which is a string, so it should say S1 equals, hello, this is a test. Okay, no surprises there. Remember in Q24 I suggested that when you print strings for debugging, that's my morning spam call. When you print strings for debugging, put them inside angle brackets so you can see if there's like extra spaces at the end and so on and so forth. So I'm going to do that here. I'm going to print S1 equals angle bracket and then print out the string S1 and then print a closing angle bracket. And so, you know, now we see, hello, this is a test. No extra spaces at the end. Whereas if we had extra spaces like that, right, we'd see clearly there's extra space at the end. General debugging thing can be useful to do. All right, so S1 is a string. All right, suppose we want to know how long it is. So we can do the following. We can say S1.length, parentheses, parentheses. Okay, think about C. If S1 was a structure, and forget about pointers, there's no pointers in Java, by the way. If S1 was a structure and it had a field named, you know, X, we could say S1.x to grab that field. Okay, and we can do the same thing in Java. We're kind of doing that here. We're saying S1.length, but length is a function. These parentheses at the end of it tell you it's a function call we're making. So there's this function length associated with this object S1, this variable of type string. And S1.length is going to call the length function on this string, and it'll return as its return value the length of S1. So if we compile that and run it, it tells us the length of S1 is 21. Okay, if we want to turn S1 into uppercase, right, so shouting S1 is, we could say S1.to upper, I think it's just to upper, but I'm not sure. We'll find out. Nope, to uppercase. And I don't know if it's an uppercase C or not. I think it's not. Nope, it is. Alright, so shouting S1 is, hello, this is a test. Okay, so what just happened here, right? We took this object S1, which is a string, and we said, let's call this function to uppercase on this string. And S1.to uppercase returned the uppercase version of hello, this is a test. So in C, you know, we would make a for loop and we would go through and we would to upper each character and we concatenate it to a string and so on and so forth. Here we can just call this method, this function, as part of S1. Right? And we could do something like, you know, string S2 equals S1 dot to upper case. Right, and we could have done that just as easily. Or if we wanted, we could do that, and that'll work just as well. Okay, so this is another thing about Java. A lot of what you think should work generally will work. At least that's been my experience. When I was first learning object-oriented programming, I tried a few different languages, and they seemed to always have exceptions. Like, this should work, but it doesn't. Java didn't do that to me. Okay, it really felt like if it seemed like it was reasonable to me, it was usually reasonable to Java as well. So it's really a language where you want to explore things, right? You'll see one way to do something. That's probably not the only way to do it. Okay, and you can work around and experiment with you know, different approaches to coding your intent, and usually it will work. There's documentation available online for all of these classes. So this is the Java documentation for the string class. Okay, and a lot of this information up here we don't really need to worry about, but there's usually a little intro here that tells you, strings are constant. Here's how we can assign a value to a string. Here's some other ways we can assign a value to a string. Some examples of using it. But down here in the method summary, this is usually where you're going to spend most of your time looking at manual pages for Java. These are all the different functions that you can call once you have a string. For example, there's a character at method. If we say string dot character at parentheses 5, it'll tell us what the 5th character of that string is, right? 5th character starting from 0. We can compare two strings. Okay, string dot compare to parentheses 2nd string, and it'll do like string compare in C. Compare two strings ignoring case. Concatenate two strings, see if one string contains another string. And so on and so forth. See if two strings are equal. Okay, just like C, we can't say if S1 equal S2, but we can do something like string compare. Well, we can say if S1 dot equals S2. And so every class that we work with, strings in this case, there's a series of methods that we can call. These are all the functions we can use to modify strings, and they come along with a string, right? Once we have a string called S1, S1 effectively contains all of this code. So if we want to find the location of a string inside another string, we can use index of. If we want to find the length of a string, we can use length. If we want to compare a string to a regular expression, we can use the matches method. Okay, everybody remember regular expressions? They're built into strings in Java. To lowercase, to uppercase, and so on and so forth. Trim to get rid of leading and trailing spaces. Value of to take something like an integer or a double and turn it into a string. Okay, and any of these things, right, you can call, you can click through and get to a more detailed specification of this. Alright, and there's links to the Java documentation on Canvas. I made myself a little dot command that just refers to a downloaded copy of the documentation I have and pops up Firefox with it. But there's links on Canvas to the documentation itself. All right, so let me motivate why we're interested in objects, other than the fact that it's required to transfer as a junior, and it's on our syllabus. So here's a program called GUI. Okay. And I've said import javax.swing.star. Import is basically like number sign include. Okay, it doesn't work the same. It's not pulling in source code, but it's basically saying we're going to use things from this javax.swing package. Okay, so when I try to construct a JFrame, right, it's going to look in javax.swing. Don't worry about the details for now. Okay, again, take this as mantra. We have to have imports in the top. So I'm declaring a class named GUI, right, because I'm in a file called GUI.java. And here's my public static void main as usual. So I have a 3-line program here. Okay, JFrame is a type of object. Okay, it's a class. So instead of saying integer I, I'm saying JFrame JF. JF is a variable or an object of type JFrame. Okay, so I'm just declaring a variable named JF, and I'm saying it's equal to a new JFrame. Okay, this is kind of like doing a malloc in C. It causes all kinds of things to happen, but it basically initializes JF to be, a bona fide object of type JFrame. And then all I'm doing is I'm calling 2 methods or functions as part of JF. The first one is called setDefaultClose operation. And this is basically saying when I close the window, my program should exit. And then I say set visible true, and this says make this JFrame visible. Okay, we don't know what a JFrame is yet, but it's a type of class available in this thing called swing. Okay, so let's compile this up. So it's compiled, and if I run it, it does something. Did anybody see what it did? It did one little thing, which is way up here in the upper left corner. It made this little tiny rectangle, okay, which if I'm good with my mouse I can expand. It's a window, it's a GUI. It's a GUI I can maximize and I can minimize and I can make small and make large, and I can close. And when I close it, my program exits. Okay, I got all that for 3 lines of code. Okay, and I didn't even really need this middle line. So this is a really powerful class, right? Just by constructing a variable of this type and then calling it setVisible method, I got a graphic object to pop up on my window, which is pretty cool. Okay, GUI2, I'm going to call one more method. I'm going to say setSize. It's another method inside this class called a JFrame. I can JFrame.setSize, and I can put in a width and a height. And if I compile that and run it, I get a window that's pre-sized at 800 by 400. All right, GUI3 is almost the same, except that instead of creating a JFrame, I'm creating something called a MindFrame. And I set the size to 800 and set the close operation and make it visible. Okay, let's see what this does, and then I'll tell you why it does that. So when I run this, I get my rectangle, but it's got a little circle drawn in the upper left corner. Okay, where did that circle come from? Well, I told it I was creating something called a MindFrame. Okay, there is no MindFrame in the swing class. There's a JFrame, but there's no such thing as a MindFrame. So what's a MindFrame? It's a class that I wrote. And it uses swing, and it uses something called graphics. And here's the declaration of the class. Now this does not have a public static void main. It's not a main program. It's a class called MindFrame, but I've said it extends a JFrame. Okay, we're going to talk about all these things in a lot more detail in the coming weeks. We're talking about something here called class extensions. But just to give you an idea of what we can do with just a few lines of Java, right? Inside this class, which extends a JFrame, I'm writing one function called paint. It's always going to take this argument. It's always going to call superpaint, and then I have one line of actual code, which is draw oval. And I'm drawing an oval at location 5050 with a radius of 7070, or maybe the other way around. I think it's at 7070, radius 5050. And that's it. By defining this class with this one paint method, right, when I run it, I get this window with a circle drawn in it, a particular type of oval. Alright, so I have a GUI4, and it looks exactly like GUI3, right, except it's invoking a MindFrame4 instead of a MindFrame. So what does MindFrame4 look like? It has a for loop. Okay, looks a lot like a for loop in C for x equals 0, x less than 800, x plus plus, x is an integer. And I'm saying y is equal to, well, it's the sine of x over 50. So I'm calling the sine method in this math class. Okay, when we want to do a trigonometric sine, it's uppercase math.sine argument. If we want to do a square root, there's a math.square root, and so on. So I'm running x from 0 to 800, I'm finding the sine of x over 50, and then I'm using this thing called fill a rectangle. And I'm asking it to fill a rectangle between these particular coordinates, in particular x and y. So it's making a little 2 by 2 square centered at x and the sine of x over 50. And if I run that, I get a window with a sine wave in it. And you know, the sine wave is fixed. It doesn't care how big the window is, right? It's just a fixed picture. Okay, same thing. Here's a MindFrame 5. Instead of drawing a little rectangle around x and y, I'm drawing a line from 0, 0, that's the upper left corner, to x, y. And if I run that, you know, I get a slightly cooler looking sine wave where I've actually drawn lines, you know, radiating from the upper left corner. And again, you know, it's just a fixed drawing. All right, let me show you one more. So MindFrame 6, right, which GUI 6 is going to draw, almost exactly the same thing, except here, you know, I drew a line from 0, 0 to x, and 200 plus 150 times the sine of x over 50. Here I'm using get height and get width to tell me what the height and the width of my frame are. So instead of just going from 0 to 800, it's going to go from 0 to however wide my window is. And instead of just scaling it by 400, it's going to scale it based on the height. Okay, the details are utterly unimportant here. The effect is what is important. So here's my same cool looking sine wave, but you know, as I change the size of the window, it redraws and fills it in accordingly. Okay. So what do I want you to take from it? The sheer beauty of the fact that I basically wrote, you know, 2 lines of code inside a for loop, and I got that sort of visual effect to come out the other side. Okay, that works because this is object-oriented. Because as soon as I say MindFrame 6 extends a JFrame, I have a huge amount of features available inside a MindFrame 6. In particular, all of this stuff. Right, so a JFrame has all of these methods available. And a JFrame is actually part of what's called a frame, which is part of what's called a window, which is part of what's called a container, which is a component, which is an object. Okay, and a lot of what you can do in a JFrame was not written by the people who wrote a JFrame. It was written by the people who wrote what a frame is, or a window, or a container, or a component. So we build on top of pre-existing things. Okay, I built on top of a JFrame. You're going to create classes for linked lists or hashes or trees, and then you're going to extend those and make more powerful things. You're not going to have to rewrite the stuff you already wrote. You're going to be able to extend it. Okay, so this is another key idea in object-oriented languages in general, is the idea of object extension. Okay. All right, so that's just a bit of sort of very fast, high-level intro / motivation for you know, why theoretically we're interested in learning about objects, object-oriented programming, and Java. So what I want to do tomorrow is go through more slowly an example of actually defining a class. We'll define a class for rectangles probably. And start looking at some of the syntax for doing that, and this is going to lead us to being able to talk about programming assignment 1. Programming assignment 1 is due a week from tomorrow, so we want to get to coding on that as soon as possible. Okay, so take a look through PA1 before class tomorrow, and we'll start talking about more details of how to actually write class definitions and do some coding in Java. All right, any questions? We got about a minute left. Raise your hand or just start talking. Awkward silence. Okay, cool.